Well, Happy New Year, students. It's wonderful to be back with you. So let's get started with our first lesson of the new year. And today we're going to start by investigating exponents. So our do now question, as always, will be first, and it is a question about resolution and goals. And students, that's something we'll be talking about quite a bit this week. I hope you enjoy that discussion. Today, though, our objective is to begin our investigation of exponents. We'll talk about what that means, which leads us to our essential question: what is an exponent and what does that mean? And what is the difference between an exponent and multiplication? So we'll think about that while we work. Our assignment today, when we watch the video, will be to complete our 2 pages. You'll see those attached in a minute. Please review all of the whiteboard activity examples I will be doing. I'll do those on our digital whiteboard here. So please pay special attention to those. And remember, you're going to show all your work, not just the answers. So our exit ticket today will be to answer a question: what is the difference between an exponent and multiplication? And then we'll also give an example. Remember, our do now and our exit tickets are done in teams. We do our practice work, our lesson, on paper, which we should have. If you have trouble finding I'm trying to get you exposed to handwriting. If you have trouble finding any of your work, your papers, please write to me right away. Email me. Remember, at the end of the period, you have to show me your work. That's how you get credit for this. So for homework, we want you to finish up in class, but if you have not finished up, just for homework, that would be to just finish up your lesson. Remember, to get full participation credit, we want to see you're there and you're participating and that you have any questions for me. We need to respond when your name is called at the beginning. It could be the middle or the end of the period. You need to hold up your work to the camera or send me a photo, one or the other. So you can either hold it up to the camera or send a photo to me at the end of the period. If you're holding it up at the end of the period and it's not finished, that's okay. I just want to see how far you got. And if you have questions, you know how to write to me. So moving on. We have our do now question. We'll talk about that. We have our exit ticket. And these are the 2 pages that we're going to work on today. There's the first page, and here is the second page. So let's go back up to our do now question. Happy New Year again. Now, it is said that goals and resolutions go hand in hand. While the resolution is the theme, the big picture, the direction you want to take your life, the goal is the specific steps that you take to fulfill your resolution. And why should you set specific goals when you make resolutions? So we're not asking you to make a resolution here. We won't be doing that for another few days. But we're just asking you to think about, why should you set goals when you make your resolutions? So I'm going to use myself an example. I put on some weight during the pandemic, and I want to take that weight off. But if I just say I want to lose weight, well, that's not very specific, and I might fail at that goal. I might lose sight of that goal. It's a big goal. Maybe I want to break that goal down, and I want to lose, 10 pounds that's the abbreviation for pounds, by Valentine's Day. And maybe I want to lose another 10 pounds. Maybe I want to lose that by St. Patrick's Day, which I believe is the 17th. And maybe I want to lose another 10 pounds by the time my birthday rolls around on June 3rd. And these are all specific goals. So if I set small goals, I can measure my progress. And if I don't quite meet my goal, I don't have to beat myself up and just give up. I'm thinking, well, it's only one part of the goal. I can pick myself up and move on. So setting miniature goals along the way are really, I think, going to help me get to my bigger goal or my resolution of improving my health by losing weight. Our exit ticket today. We'll complete that after we work on our lesson. So let's get started on our lesson. So remember, I hope you took a minute to respond to the do now. Make sure that you wrote something here, okay? We're just not asking you to make a resolution. Just why is it important to set goals? Okay, that's all I want you to answer. So, okay, our lesson is on exponents. So, with the exponent, we have two parts. We have the base, which in this case is this 8, and we have the exponent, which in this case is the 4. Now, I want to go to our whiteboard. I want to talk about this a little bit. So, we can think of an exponential value as repeated multiplication. So let's understand what that means. If I have 5 to the second power, okay, I'm talking about 5 times 5. Remember, I don't like to use x generally for multiplication. I like to use that little dot. And what is 5 times 5? That's 25. Also a perfect square. We'll talk about those next week. 5 to the second is not 5 plus 5. And let me tell you the mistake that I often see. If I ask a student, what is 5 to the second? They'll say, oh, 10. Okay, that is incorrect. Okay, that's where my X is. That's wrong. What did this student do when they did this? Well, they did 5 times 2. Okay, 5 times 2 equals 10. Well, what is 5 times 2? 5 times 2 is 5 plus 5. We have 1 5, 2 5s. 5 times 2 equals 10. Okay, that is not an exponential relationship. Okay, an exponential relationship is what I just circled in green. We have the base, which is the 5, and the exponent, which is 2. And the exponent says, this is how many times I multiply the base by itself. So let's write that out. I have the base and the exponent. Okay, the exponent says, this is how many times, let me straighten that out a little bit, how many times I multiply the base by itself. So in the case of 5 to the second, we multiply the base by itself 2 times. 1, 2, to get 25. Let's try it with another number. So 3 to the second power is not 3 times 2, it's 3 times 3. 3 multiply it by itself 2 times. What is 3 times 3? 9. Okay, it's not 6, it's 9. What is 3 times 4? Well, that would be 3 times 3 times 3 times 3. Well, 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. So 3 to the fourth power equals 81. So what is an exponent? What is an exponent? An exponent is repeated multiplication. I hope you're writing this on your paper in your notes somewhere. And what are we repeatedly multiplying? The base. And we say the base is multiplied by the number of times in the exponent. Let's do another example. What about 2 to the 4th? Well, that would be 2 times 2 times 2 times 2. Let's evaluate that. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So 2 times 2 times 2 times 2 equals 16. So let's work on those worksheets. Okay, so we said that we have the base and we have the exponent. So here's our base and here's our exponent. So 8 to the 4th means 8 times 8 times 8 times 8. Now we can add exponential expressions. So we can add 2 to the second power plus 3 to the second power. And what would that equal? Well, 2 to the second power is 2 times 2, and 3 to the second power is 3 times 3. So 2 times 2 is 9, and 3 times 3, 2 times 2 is 4. I was doing my 3 times 3. 2 times 2 is 4. 3 times 3 is 9. 9 plus 4 equals 13. So let's do some practice. We are asked to write each expression using exponents, and then we're asked to simplify. So it says 9 squared. Squared is an exponent of 2. Okay, so that would be 9 squared, and that equals 9 times 9, and 9 times 9 equals 81. Okay, so the base is 9, the exponent is 2. The base is multiplied by itself 2 times. When we evaluate that, we get 81. Now 4 to the 5th power is 4 to the 5th power, written like that. That's 4 times 4 times 4 times 4 times 4. That is not, let's make a note here, not 4 times 5, okay? Not 4 times 5. That's 4 times itself 5 times. And 4 times 4 times 4 times 4 times 4, you can use a calculator, is 1024. That's right. And that's the thing with exponential values. They increase very quickly. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. 256 times 4 is 1024. It adds up really quickly, or multiplies very quickly. Now we have 8 to the 4th power. So that would be 8 with an exponent of 4. So that would be 8 times 8 times 8 times 8. So let's work this out. 8 times 8 is 64. Okay, now we have 64 times 8, which is 512. Now 512 times 8 is 4,096. And if you took your calculator and you typed in 8 times 8 times 8 times 8, you would get 4,096. These numbers get very big very quickly. So now we have 11 cubed. So that's cubed means to the third power. To the third power means an exponent of 3. So that would be 11 times 11 times 11. So 11 times 11, you may know this from your math facts, is 121. And then 121 times 11 is 1,331. So 11 times 11 times 11 is 1,331. So let's finish up. We have one more page, and it looks like we're doing some error analysis here. I love the error analysis because it shows that we're really paying attention to our work. So let's look at that error analysis and let's take a look at what the mistakes are. So we have a base of 9 and an exponent of 3, 9 to the third power. And look what I see, 9 plus 9 plus 9. No, 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 no. That's really 9 times 3. That's repeated addition. Exponents are not repeated addition. They are repeated multiplication. So let's write that down. Exponents are not repeated addition. And so what should that be? Let's solve it correctly. 9 to the third should be 9 times 9 times 9. And if you get your calculator out, 9 times 9 times 9 equals 729. All right, let's look at the next one. It says 5 to the 6th power. And look what they have here. This is 5 times 6. This is not 5 to the 6th power. 5 to the 6th power is not 5 times 6. So what should it be? 5 to the 6th power is a base of 5 multiplied by itself 6 times. 5 times 5 times 5, that's 3, 4, 5, 6. Now, you definitely need a calculator for this, and you don't want to punch in 5 times 6, okay? Not 5 times 6. You would put in 5 times 5 times 5 times 5 times 5 times 5, and you would get 15,625. And if we had calculators, I could show you, maybe when we're in class together, I can show you how to actually use the exponent function on the calculator. So let's take a look at 2 to the third plus 4 to the fourth. 2 to the third is 2 times 2 times 2 plus 4 to the fourth, which is, there's my 2 times 2 times 2. 4 to the fourth is 4 times 4 times 4 times 4. That looks correct, but the problem I see is right here. This should be addition, okay? So let's do this correctly. So it's 2 to the third power plus 4 to the fourth power. So that means we're going to have 2 times 2 times 2 plus 4 times 4 times 4 times 4. Okay, so 2 times 2 times 2 is 8. And 4 times 4 times 4 times 4 is 256. So 8 plus 256 equals 264. All right, let's look at the last one. 12 to the fourth power should be 12 times 12 times 12 times 12. So let's look at what we have. We have 12 times 12. Here's the problem. Plus 12 times 12. Okay, so should be multiplication. This plus sign here should be multiplication. So let's solve that correctly. 12 to the fourth power would be 12 times 12 times 12 times 12. And I have to tell you, honestly, I used my calculator for this. I often don't like to use the calculator, but I needed to for this because when I multiply 12 times 12 times 12 times 12, I get 20,736 as my final answer. So that's your introduction to exponents. We'll be doing these for a bit. Let's go back up to our exit ticket. And what is the difference between an exponent and multiplication? So multiplication is repeated addition. And exponents are repeated multiplication. And let's give an example. So 3 plus 3 plus 3 plus, let's just do 3 threes. I don't want to make it too hard. 3 plus 3 plus 3 equals 9. And we'll change our color here. But 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So this is repeated addition. This is repeated multiplication. Another way to write 27, 3 to the third power. So thank you for doing your work today. Thank you for prioritizing your math and wanting to be your best at all times. I appreciate how well you work. I appreciate how you put your thinking cap on when you're doing your math. And even when it's a little bit not fun and you struggle a little bit, I appreciate how you just stay with it. Stay with it. Students, stay with it and make sure to show me that you're working because I love being proud of you. And it just makes me feel so good that you work so hard and that you're trying to get ahead. I wish for you a happy new year, good grades, and extra practice, because when you do, you'll be great.